Thanks.
Oh,
Okay, this morning I'm going to talk about a tool that we're building at MIT that's hopefully going to be making some of your lives easier soon. So I don't need to go into a detailed explanation here, but the bottom line, which I'm sure you're all aware, is because of the highly flexible, configurable nature of BGP, we think that BGP, in addition to being viewed as a network protocol, should also be viewed somewhat as a distributed program. And this type of view suggests that we need practical verification techniques to verify that once you've got your routers configured or your program written, when you turn all those routers on, everything's going to go as planned. So again, you probably know this slide better than I do, but let me just describe to you my perception of the state of the art as far as configuration debugging, right? So operator decides that he wants to make some sort of change, tweak an IGP policy, route map, et cetera, at a customer, makes that configuration change. That configuration change is logged in sort of a CVS diffing style tool, similar to those that were described yesterday. Everything seems fine. Sometime later, some strange behavior might appear, and that behavior might be hard to link to any particular change that was made. So the reasoning process that transpires is something like, well, when did this problem start showing up? Let's try to roll back the configuration to the time before we started seeing that problem. Just sort of revert the configuration, hope the problem goes away, and continue tweaking, right? So imagine if you had to write C or Perl or anything like this, right? It'd be hard to actually get anything done. And I would argue that this is not an appropriate programming environment for operators. It's ad hoc, it's painful, it wastes a lot of time, and people get angry while you're doing these types of tweaks. And the other point that I want to highlight is that the type of error checking where you make a change and then see if everything's all right at the particular time is not really optimal, right? A problem could show up. A problem could appear much later than at the time at which the configuration change was made, right? A failure could happen at some point later and cause something to go wrong that was not apparent at the time of the original configuration change, right? So you want to have some sort of tool that tells you at the time you make the change, this type of problem is likely to happen at some point in the future, or warning, the change that you made is not really a recommended change to make your life happy in the future. So we're looking at building a tool that does a little better job of verifying what we call configuration correctness. And I'm going to talk a little bit more about what I mean by correctness. And by all means, I'm open to feedback here. I'm just going to throw out some ideas, and you may have some ideas of things that you consider to be correct behavior, and I'm definitely open to feedback there. But I've got some ideas that I'll describe, and I define correctness in terms of these correctness properties. So when you talk about verifying configuration correctness, you want to verify it in terms, systematically in terms of some set of properties. I've got a configuration: is property A satisfied? Is property B satisfied? Etc. Then how do you go about verifying whether your configuration satisfies those properties? Well, you figure out the aspects of configuration that could affect those properties, and then say, do those configuration commands on these routers satisfy the particular set of constraints that I've set up for that property? Now, you could talk about configuration in a number of ways. You could talk about, have I got this particular router configured properly? Have I got this set of routers in my autonomous system configured properly? Are the routers in my autonomous system going to play nice with routers in other autonomous systems, et cetera? And we haven't fully considered all of those questions. In particular, things that involve configuration across multiple ASs. Those are questions that we haven't figured out what to do about. But in particular, the tool that we've built thus far and the problems that we're focusing on are configuration problems that go wrong inside one autonomous system. And I'll give some examples in a minute. But so what this talk is really about is thinking about ways to reason at a higher level about what goes wrong in configuration, and then building a tool that's based around that reasoning framework. So that's really the first point. Let's take a set of existing configuration, router configurations, and verify that certain properties hold. I should mention that the tool that we've implemented so far is meant to sort of chomp on Cisco iOS configuration. It can be extended to other existing vendors. But also, let's say that we have a completely new configuration language. This type of tool is always going to be necessary, right? You're always going to want to be able to chomp on configuration files and say, I've got this property satisfied, or I've got that property satisfied. So no matter what configuration language comes along, we're always going to want some sort of higher level validation that what we're doing makes sense. And second, something that we're thinking about that I'm not going to really talk about a lot in this talk, but that I'm going to sort of wax philosophical about at the end, is that a lot of verifying correctness of routing configuration depends on verifying that what I've got configured in reality jives with the intended behavior of what I want to actually have happen. And in order to verify that that's going on, I have to have some way of specifying that this is my intended behavior. So the insight there is, once that I've specified this intended behavior, why don't I use that specification of the intended behavior to actually be the router configuration language? So I'll talk a little bit more about that at the end, but mostly I want to talk about how our verification tool works. So let's just sort of first get a little more concrete, right? So talking about configuration, talking about correctness properties, let me just talk about one that I call information flow control. Let's sort of examine a very simple rule. Let's say autonomous system B is hearing routes from C, one of its peers, and wants to make sure that those routes aren't re-advertised to A. Well, how does this happen today? I would argue that the way we do this today is really not the way we want to be doing things, and it's very error prone, right? What's going on is you've got a high level policy. Don't advertise the routes I hear from one peer to another peer. And I'm specifying that policy in terms of a mechanism. A route comes in, tag it with this community, re-advertise it to these routers, et cetera. It goes over to this router. If the route has a particular community, don't re-advertise it, right? So there are a number of things that could go wrong there, right? I could specify the wrong route map. I could forget to define the community list. I could tag the route with the wrong community, et cetera. And there are all sorts of things that could go wrong. I mean, these are the types of things that we want to check at a higher level, right? At the end of the day, is the route from C going to be re-advertised to A? And there are all sorts of tricks that people try to play that fit into this sort of property that I call information flow control. Things like partial peering or prefix propagation, conditional announcements, etc. And you want to make sure that when your routes are coming in, being manipulated a certain way, passed on to other routers, and eventually sent on to other autonomous systems, that things are being passed on in the way that you expect them to be passed on. Okay, so in addition to information flow control, we've got a whole bunch of properties that we suggest are things that fall into the realm of correctness properties. So I'm not going to belabor these points, but I just want to illustrate that these are sort of the 5 areas that we've sort of highlighted as kind of important things where routing configuration can go wrong. And I've listed underneath each point examples of configuration mistakes or conceptual misunderstandings that can cause each one of these types of properties to be violated. So the idea is when we're writing our configuration checker, and as we've developed it so far, we keep these properties in mind and try to figure out, okay, let's say I want to write a check to make sure that validity or visibility is violated. What types of things affect these properties, and how can we write rules that make sure that that allow us to say whether or not property A is satisfied or is not satisfied. Okay, so the rest of the talk I'm going to talk about the tool that's sort of motivated around this reasoning framework, which we call Rolex. If the lawyers come after us, it'll probably be renamed to MIT Project Rolex. Let me just sort of describe to you what we have so far, and then later on in the talk, I'm going to describe to you things we're thinking about developing for the tool. And as you see at the bottom of the slide there, there's a URL you can visit. You can send us feedback. That's one of the reasons I'm here, actually, is to try to get feedback on what types of checks you think are important, features, bugs, try it out, etc. But for the rest of the talk, I'm just going to talk about what we have today and what what you can download today. And that's actually what I've shown here. Basically, the tools thus far is a tool in two parts. And the first part is something we call a pattern-based constraint checker. And if you're familiar with things like Yak or anything like that that sort of matches on patterns and then sort of executes a finite state machine to figure out what state the configuration's in at any particular point, that's kind of what the pattern-based constraint checker is. And I'll describe that in a little more detail in a bit. And then the other piece is basically working towards that sort of talking about information flow and things like that. The example that I described before, basically you want to get some high-level representation of what's going on in the network. And the control flow analyzer is basically just a way of sort of browsing what's going on in the network, who's connected to who, what route map do I have configured on this router, etc. Okay, so let's talk about this pattern-based rule checker first. As far as using it, it's very easy. It's just as simple as running the script. I've included a couple of examples for the script in the distribution. And basically, what happens is you run the script. I should say also that the tool is designed to chomp on the configurations offline. Maybe you could combine it with some of the functionality that's some of the tools that were described yesterday to run it online. But basically, thus far, I've designed it to chomp on offline configs. Okay, so you run the script. It grinds away and then gives you some errors. I should mention that the way that we've designed the rules is you can kind of write them in a way that kind of makes sense. That says, if I've got a router here and a router there, I want to make sure that the constraints between these two routers are satisfied. And it's very easy to write rules that are distributed across multiple routers. And I'll show you an example of that. So here's 3 examples. I'm going to describe each one of them to you in turn. The first I sort of throw in the category of validity. And what this rule, the output of this test is showing is based on a rule that has to do with the next hop self setting. So what this rule says in English is, if I've got an eBGP session, that session should either have next hop self set or the IP address of the loopback on the other side should be injected into my IGP, right? So the reason I throw that in validity is obvious, right? If you have neither of those cases, then you've got a route somewhere inside your AS where a router doesn't know how to get to the next hop. So that's bad. I should also say that these examples they're based on reality, but I've fictionalized router names and AS numbers and IP addresses to protect the innocent. Okay, so as you can see, sort of the output, you run this particular test, and you see that this particular gateway in Atlanta has an eBGP session. Next hop self wasn't set. Oh, and here we've got an error because the loopback address that's on the other side of that session was not injected into the IGP. So then the output of the next test that I've shown, I throw into this visibility category, right? So is there a path, but for some reason the BGP route is not being advertised, right? So what this test says is, if I've got a router that's that's got a BGP neighbor statement to some other router, let's make sure that, and that's an iBGP session. Let's make sure that somewhere in my configs, I've got a router configured with the loopback of that router, the IP address that that corresponds to that neighbor statement. So first 3 lines showcases where, for example, there's a router in Boston that's got a neighbor statement with this particular IP address, but I can't find any router inside my autonomous system that has the loopback address set to this IP address, etc. And then the test cranks away, and it also finds other things. The last line there shows, for example, that I found a router where there was no BGP statement set at all. Maybe that's good, maybe that's bad, but it's at least something you should know about, right? Perhaps it violates some assumptions. And then there are things that I would throw into this determinism category. Is deterministic med set? Is best path prepare router ID set, etc. And output at on the third test there shows sort of what would come out for running that test. Okay, so let me just describe some details for your for those of you who are interested in how this pattern-based checker actually works. As I mentioned, it's kind of based around this sort of YAC model where you match on a particular pattern and then go into a particular state depending on what patterns I've seen. And as I mentioned, it's easy to spread this across routers in an autonomous system. So it may be difficult to read there, but basically the FSM starts at the top. It looks for any, R1 will basically match on any router. It's looking for a router BGP statement with a particular autonomous system number that'll match any AS number, and then a neighbor statement with an IP address and remote AS. Once I've matched on that statement, I bind the loose variables and say, I've got a, on router in LA, I've got a router BGP, 701, neighbor whatever, remote AS whatever, and then I go through the graph and sort of figure out what state you're in, and then at particular points you can sort of hop off and either say, okay, this configuration for this particular router, it's and set of routers is okay or it's not okay. So how do you actually specify one of these FSMs? Well, in the tool itself, I've given a bunch of examples, but presumably, there are going to be a lot of examples that I didn't think of, or I'm just not aware of because I don't configure routers on a daily basis. So I try to make specifying these types of rules particularly easy. So this rule that I described with the next hop self and making sure the IGP, the IP address is injected into the IGP, et cetera, was the FSM that I showed you on the previous slide, and that can be written in sort of it's basically written as a Perl module, and what the tool does is provide the finite state machinery, and all you have to do is sort of write the transitions, or all I have to do rather. So basically what this 41 lines of code does is basically just spec out what that FSM looks like. What are the nodes, what are the transitions, etc. So this is the one that I've sort of shown from the previous slide. I'm in a particular state. If I match on a particular pattern, go to this state. And it's that easy. And as I mentioned, there are things that I haven't thought of that you probably encounter on a daily basis, and that's the type of feedback I'm looking for here. These are the rules that you should have, or if you feel so inclined to write some of these rules yourself, I'd be really happy, and I've tried to make that easy. So let me just briefly talk about the second part, which I call the control flow analyzer. And we're not to the point of actually checking high-level properties here, but I think that the tool, as it stands, is actually something that's pretty useful. Basically what it does is chomp on router configs and give a high-level summary of what the network state is at a particular time. So it's got a number of features. One is it allows you to sort of graph the network at a router level. And then the nodes are basically routers, and at the edges are import and export route maps labeled with some canonical number so that 7 here is the same as 7 on that edge. And when I say route map 7, I'm speaking of some normalization of what that route map actually does, not what it's called. So if you've got a route map called customer on a New York router and a route map called customer on an LA router, but they actually do two separate things, I'll call that two separate route maps. So this is sort of a again, I've sort of anonymized away things to protect the innocent, but this is sort of a snapshot of just a little piece of what that network graph looks like. And it's probably more useful for smaller types of networks. For larger types of networks, you want to use, let me just go back. You want to probably use the second part, which is this database-backed web interface. So what this does is sort of chomps on the router configs, throws everything into a database, and then allows you to sort of browse what's going on from the web. And I'm going to show you just a brief example of the things that you can do with the tool as it stands. So for example, you can look at all the routers that, I'm sorry, all the BGP sessions at a particular router. So you can say, give me the BGP sessions at this gateway router in LA. And it'll say, oh, you've got 2 sessions to a particular AS, and here are the import and export route maps that you're using on those sessions. And again, the route map numbers are normalized based on what they do, not what they're called. Okay, so other things that you can do is sort of look at the number of sessions that you've got to a particular autonomous system. So you've got four BGP sessions off to 1239. Let's see what those are, right? So click down, drill down, and see what those 4 sessions are. You can see I've got BGP sessions to 1239 at these 4 routers, and these are the import and export route maps that I'm looking at. So one thing that I want to highlight here is that it's pretty easy to see differences of I treat the incoming routes a particular way at 3 places, but I treat them a slightly different way at a third place or at a 4th place. So what the tool then allows you to do is say, well, that looks different. Let's sort of see what's going on. So with you sort of click down on that, and you see what these 2 route maps actually are. And then what the tool does is provide you a diff that says, here's the sort of difference between these 2 routes. So this slide may be hard to read. Even if you can't see it, you may not understand what's going on. But as I mentioned, I've normalized the route maps away from what they're called as to actually what they do. So basically what I've done is dereference community lists, basically dereferenced everything and sort of said, this is actually the mechanism of what the route map does, and then actually run the diff on those two specifications. So you saw some tools that did config diffs yesterday, and I just want to highlight what the difference is here, right? So yesterday they were talking about configuration diffs in terms of time, right? I make a change at a particular time, and I want to see the difference between what my route map or what my configurations look like today versus what they look like 5 days ago. This is not that. This is I've got a configuration on a router in LA, and I've got a configuration on a router in New York, and I want to see what the difference is. Okay, so that sort of summarizes what you can do today with the tool. And I just want to briefly just wax philosophical about sort of things that we're thinking about and what you might eventually want to do. So let's imagine what you could do if you could take that sort of high-level network summary, like this is your 10,000-foot view of the network. Let's actually figure out if we can run some constraints or verify properties based on that. So if you had some way of specifying, this is what should be going on. Don't re-advertise the routes that I hear from peer C over to peer A. Let's sort of match that up with the high-level description of what's going on and see if that actually matches up with reality. So going back to our example, right? As I mentioned, specifying the policy with mechanism is complicated and it's hard to get right. But how do we actually tell whether this is doing the right thing or not? Well, we need some sort of specification of what should be happening. And I think that's a key challenge, and that's something we haven't really figured out. One thing that's tricky, right, is it's easy to say you've got peer A and you've got peer C, and you don't want the routes from peer A going over to peer C, and you can sort of specify that with information flow lattices, etc. But it's probably more complicated than that, or at least I think it's more complicated than that. You should maybe tell me if I'm wrong, but you may want to treat things differently based on what the AS path is, what the prefix is, what router it's coming in on, etc., etc. And if you get to the point where specifying the high-level property is as complicated as specifying the configuration itself, then you're in trouble. So the real question is, how do we make the configuration specification as simple as possible so that we can check whether these low-level things are actually happening, and that we can actually make it easier for network operators to say what they mean rather than say what they want to happen when a route comes in at a particular router and goes out at another router. So just to summarize what the control flow analyzer does, it basically just provides a bird's eye view of the network and allows operators to view what's going on in terms of where my BGP sessions are, what route maps I'm using where, et cetera, and it's fairly navigable. There's some other things you can do as far as restricting what shows up, et cetera. And there's some things that we want to add sort of immediately. One is that it would be natural to use this type of thing to ask a question: what happens if I get a route advertised on a particular session at a particular router? Where does that route propagate to? What attributes get manipulated, and where does it pop out? What eBGP sessions does it come out on, for example? Okay, so as I mentioned, once you have this specification, it's natural to say, let's not only can we use this specification to check existing configurations, but why don't we just use this high-level specification as the router configuration language itself? So as I mentioned, the first set of questions sort of gets at this problem, right? We want to make something that's simple for people to express what they mean, yet allows for enough detail so that you can actually do what you want without getting burdened with the same type of complexity. Okay, so finally, I just want to thank a couple of people who have provided me with many helpful insights on this work. Jennifer Rexford from AT&T, and also Randy Bush gave me some advice that hopefully made this talk a little more interesting for you guys. If it wasn't interesting, maybe you can throw some of the blame on him too, right? And finally, I just want to say that I think we've got a symbiotic relationship here, right? It seems to me that you've got a problem as far as router configuration causing you a lot of headaches, and I've got a problem, and that's I'm still at MIT and I'd like to leave eventually. So let's work together. You give me some feedback as far as what would be useful in a tool like this. What types of problems are real? What types of things do you want? How can I make your life easier? Download the tool. Test it out. Or if you want me to test it out on your stuff, I'd be more than happy to do that. I'm more than happy to write tests that you think would be helpful for your network. I'm an expendable resource at this point. I'm a grad student, so I've got time on my hands. Just let me know what I can do to help you, and thanks for listening.
I actually have a question. I didn't think I'd have questions today, but I do. In my experience, which, God knows I don't run a network anymore, but in my experience, I named route maps things on purpose. And so to have a tool that took those names away and called them something else, even if they didn't do the same thing, would make them somewhat meaningless to me. So is there a way, or have you thought about incorporating both? So maybe I have 52 route maps that say customer, okay. And to me customer is an important thing, and they might do different things, and it might be useful to know they do different things, but it might also be useful for me to understand that those are all the customer route maps.
Yeah, I think that's something that would be easy to add, and that's the type of thing that is helpful for us to know. The reason that I was motivated to do it this way is that my hypothesis is that occasionally you've got sort of a cut and paste type of thing where I've got a customer route map. I'll just copy this one, and then at some point maybe I do some load balancing. I make a little tweak. And 5 months later, I come back and they appear to be called the same thing. Or, especially if I'm looking at a 5 neighbor statements or something where they all say customer. I look at a different router and I've got customer there, and I might assume that that's the same thing, but I think that it's important to see that it's not. But I do agree that something that also allows
if it
operators
had both,
to see what it's called.
It would be great.
Yeah, but that was my motivation.
Yeah, well, it makes total sense, but it would be nice to have both, because then you could reconcile what you intended with what you have.
Yeah, definitely.
Okay. In the front.
Okay, Owen DeLong, Tell Me Networks. Your rule-based parser, or I forget what you called it at the beginning, but
I know
the thing where you feed a set of rules in and you feed the config in, and it sort of tries to do pattern matching between them.
Right.
The rules that you have to feed into that, or the patterns that you have to feed into that, is there any possibility of perhaps generating those from RPSL or something similar?
That's a good idea, actually. I hadn't thought about that. Actually, in fact, one thing that I didn't mention that is kind of a problem with that is the sort of manual nature of having to write those specifications, and that's a big pain in the neck, right? So I've thought about ways where maybe you can kind of infer some of these rules. Like, let's say you've got, let's say you've got some sort of configuration option that's turned on 98 routers and it's off on 2. Maybe you could say that let's call that a rule that says this thing should be turned on in this particular way. That's another way I've thought about doing this, but using RPSL to generate rules is also a great idea.
Yeah, because we're already having to go through that pain. At least some of us.
Yeah.
The other question I had is, currently it looks like you're primarily parsing iOS configs.
That's correct.
Is there any, and it looks like as you parse those, you're sort of abstracting them as the first step before you do anything else with them.
That's correct, yeah, I'm trying to get away.
So it would be nice if we could sort of separate that adaptation layer so that, and, you know, open that process up so that it would be easy for you and also for other people to build sort of modules that would allow you to parse other vendors' configs.
Yeah, that would be excellent. Yeah, as I mentioned, I think what we're trying to do is independent of any router configuration language. So that's definitely a point that I'd like to get to, and hopefully someone else will write, you know, config parsers for other languages because there's only one of me. But yeah, getting to that point would definitely make that a lot easier. So yeah, that's a great suggestion. Thanks.
Dave?
I just had kind of two questions. I don't know if they're questions or comments. I just wrote down some, and some of them kind of been covered. But one of the things that I've noticed is that we have some tools that are kind of syntactically based, like Rancid.
Right.
And then we have something like what you're trying to do, which is trying to bring some kind of understanding of the semantics of what these things are trying to do
Right.
to management of configs, right?
Right.
So are we on a track where we're going to have a proliferation of tools, or are these things, is there a place where these things can come together so that, you know, I have a kind of a unified management of my config space? That was one thing, kind of a thought I had while you were talking. And the other one was, and I think I want to mention this, is that you're developing a meta language for router configuration, and we've talked about this over the years millions and millions of times. And we tried to do it with RPSL, and you can argue up and down whether or not RPSL failed or succeeded or whatever. Maybe it was too ambitious to try to put the database thing there or whatever, I don't know. But is that where this is all going, that we think that our vendors are going to supply us a language like, you know, maybe ANSI standardized router language or something like that? I don't care who does it. I mean, but you know what I'm saying. You know, some kind of standardized router. I was thinking of C. So, you know, some kind of standardized router language that they all speak the same thing. And if we do that, then how do, I mean, I'm just trying to see how that fits into the space of what vendors do, which is try to kind of distinguish themselves by value added while at the same time being interoperable. So I was just interested in what you thought the direction there was.
So first question about Rancid and things. So actually, I think these tools are fairly complementary and actually might, rather than proliferating, I mean, eventually it might make sense to think about one tool that does all these things. I mean, you think about what Rancid does, and it's got a lot of, I mean, it tries to tackle a lot of problems that are definitely very necessary, but it's things that we aren't looking at all, like, you know, doing mass configuration, you know, looking at route map diffs over time, like the whole CVS thing, and looking at differences. That's all very useful, and that's stuff that we're not looking at all. But you could imagine combining, you know, things like what Rancid does with things like what our tool does, which is, you know, now I've made a change, you know, chomp on it with a tool like mine, and you figure out, you know, oh, you're likely to have a certain problem, and then, well, let's see what we've done, you know, let's see what this looked like, you know, in the past with Rancid,
Exactly, because what many of us do is we have, you know, cron scripts that run against our routers, so that, or our Rancid thing, and so at some point it says, hey, this route map changed, but that's all you know, right? You got to go figure out what that did, right?
Right. So, I mean, so I recognize that that's, you know, something that you want, and I think something that you also want is something that actually explains, you know, this changed and it's likely to cause X, Y, and Z to go wrong. So that's where I think, you know, the two tools together could actually, you know, be quite useful. Oh, so as far as the second question with configuration languages, yeah. So I guess, yeah, I'm not sure exactly what all I should say there, except that I think I want to take the position that specifying your policy in terms of you know, what the router should do in terms of when a router arrives, and you know, import-export policies, et cetera, and actually the mechanism of how a route is manipulated. I think that you know, we should be moving towards actually specifying the policy in terms of the policy and not in terms of the mechanism. And yeah, so I'm trying to, you know, get people's attention on that, and we'll see how far that goes. That's all I want to say.
Rudiger?
Okay, Rüdiger Volk, Deutsche Telekom. Well, okay, I have 2 points. One is I'm not quite sure how close you are actually to getting to some common router language. Even the terms you are describing your tools in terms of not grammars but patterns kind of hints me that, well, okay, having actually an abstract model of what you're dealing with, which could be mapped into a language for describing router configurations. Well, okay, I'm asking, are you doing something there, or are you just abstracting from what you're seeing on a particular vendor, and when the next one comes up, you have to retrofit and, well, okay.
Okay, so I think in my view, there's 2 things that are going on. One is you've got kind of what's happening in reality, right? These are the routers that are in your AS. This is what's going to happen when a particular route comes in. It's going to be re-advertised here, here, and here. It's going to local pref's going to be manipulated, med, etc. Right? So that's you want to sort of view that at a high level, away from what the Cisco iOS looks like, what the Juniper looks like, etc. So that's one thing, and I think you're always going to want to do that, independent of whatever the language is, right? No matter what Cisco or Juniper or whatever decides to do in the future, you're always going to want to be able to sort of view at a high level what's going on in terms of where my route's going, how am I treating this particular AS in terms of how am I treating its routes at these different locations, etc. So I think that's always going to be useful. Now, there's a separate question you can ask there, right? So that's sort of like a representation of what's going on. And now I want to ask, does that representation agree with what I think I want to have happen? Mm-hmm. So then you can ask, how do I actually specify what I want to have happen? And that's sort of a language question and something that I don't have good answers to right now, but I think it's something that we should be thinking about. And to sort of get back to the previous question about RPSL, I mean, you look at RPSL and it's still sort of very mechanism based, right? And I'm sort of advocating, independent of the mechanism, if we could have a way where, you could actually say what you meant to have happen in a way that's actually simpler than, I want to prepend this thing out 10 times, or, I want to assign this community. That's not actually what you want to do. That's just sort of describing how you want to get it done.
Yes. Well, okay, I'm getting some work on that done. But
wait.
Let's do the second one offline. Sorry, but we are running late.
Yeah.
Thanks. Thank you.
Thanks.